Hi everyone, today I am going to talk about electrochemistry, where we are going to concentrate about the basic concept of electrochemistry as well terminologies which is involved in the electrochemistry concepts. Right. My general objective for this topic is going to be at the end of the class you might be able to understand the basic concept of electrochemistry as well the terminology which is involved in the electrochemistry. So this is going to be my general objective of this my topic, and specific objective of this topics are going to be the first one. At the end of the class you might be able to understand the basic principle of oxidation. So this is the process which get involved in the electrochemistry concept. And my second specific objective of this topic is going to be reduction. Now at the end of the class you must be able to understand what is mean by reduction process. My third objective is going to be redox reaction. So at the end of the class you must be able to understand what is mean by redox reaction. So it's nothing but it's a combination of oxidation and reduction, right? And my fourth objective is going to be electrode potential. So at the end of the class you might be able to understand what is mean by electrode potential and how it can be measured. And simply it can be represented as E, electrode potential and it measurement. So these four are the specific objective for this topic. All right. Now we will going to the deep into one by one. The first one. What is meant by electrochemistry? So basically electrochemistry is nothing but it's a part of chemistry, it comes under physical chemistry. Here we are going to deals with the electricity as well chemical reactions. That means how the electricity influences the chemical reaction, both forward as well as reversible reactions. So this is the basic principle which is involved in the electrochemistry. All right, and terminology. So if we want to understand the electrochemistry deep into that, you must aware of the following terminology. What is the terminology? The first one, electrolyte. Now, what is meant by an electrolyte? So electrolyte is nothing but it's a substance, or we can say that aqueous solution of salt solution. Say for example, you can take it as NaCl, sodium chloride. When sodium chloride is dissolved in water, it will give an electrolyte. So this is strong electrolyte. So whenever we introduce sodium chloride into the water, it becomes Na plus and Cl minus. So it will conduct the electricity, because when you pass electricity to this NaCl solution, the movement of ions will take place with respect to the sign of the electrodes. The positive ions migrate towards negative electrode and negative ion moves towards positive electrodes. So therefore electrolyte is nothing but it's a molten salt solution. And second, the second terminology involved in the electrochemistry concept is electrodes. Now it has got two classification. One is an anode and the second is going to be a cathode. Anode and cathode are electrodes of the particular cell or particular battery, whatever may be the case. And the third one, electrode potential. Electrode potential. Now we are going to concentrate about what is meant by anode and what is meant by cathode. And before that you are supposed to aware of the basic concept of electrode. Now how we can construct an electrode? So electrode is nothing but we can take any metal, let's say zinc metal. Now I am going to take a zinc metal. So this is going to be a zinc metal. When zinc rod, right? So the zinc rod is consists of zinc atoms, and these atoms are binded together with the help of valence electrons. Okay, the zinc metal may contain n number of metal atom, and you will have n number of valence electrons. Now these metal atoms are binded together with the help of metal ions. Now when the metal atom are binded together with the help of valence electrons, it forms one solid zinc metal. Now the zinc metal, now I am going to immerse this zinc metal in zinc sulfate solution, right? Now this is going to be a zinc sulfate solution. when zinc rod, this is zinc rod, when zinc rod is placed in a zinc sulfate solution, now this setup is called as an electrode. Now I will tell you why it is called as an electrode. So basically, whenever the metal is placed in its own salt solution, it will have two type of tendency. One is called oxidation, and the second tendency is going to be reduction. And the oxidation and reduction behavior of the particular metal depends upon the nature of the particular metal. Alright, now I will explain what is meant by oxidation. So oxidation is nothing but it's a chemical process in which electrons are removed from the particular metal. For example, as I told you earlier, the metal atoms are binded together with the help of valence electrons. Now we are going to remove the valence electrons. For example, if it is a zinc rod, okay, it consists of zinc atoms. Now the zinc, we are going to remove valence electrons. So basically, if it is a zinc, the stable oxidation state is 2 plus. Now we are going to remove 2 number of electron from the zinc rod. Now it becomes electron deficient species. Zinc is converted into zinc ion, positive ion, and we are going to remove 2 number of electrons. So this process is known as oxidation. So therefore, oxidation is nothing but it's a chemical process in which electrons are removed from the particular metal. So this is called oxidation. Alright. Now reduction. What is meant by reduction? Reduction is also kind of chemical process in which electrons are added to the electron deficient species. Let's say if it is a zinc ion, is it 2 plus. Now we are going to add 2 number of, so this is 2 electron deficient species. Okay, now we are going to add 2 number of electron to this electron deficient species, and when you add 2 number of electron, it will attain the zero oxidation state, becomes zinc, metal atom. So this is called reduction process. And whenever these two reactions happens together, that's called redox reaction. So redox reaction is nothing but it's a combination of oxidation and reduction. So this redox principle is highly useful in all the storage devices. Alright. So now what is going to happen? When you place a metal rod in the zinc sulfate solution, as I mentioned earlier, it may undergo either oxidation process or reduction process. However, that oxidation or reduction tendency depends upon the nature of the metal. And for this, we are going to use one more concept called electrochemical series. We will discuss the concept in the upcoming sessions. Alright. Now, what is meant by what type of metal will undergo oxidation and what type of metal will undergo reduction? According to the electrochemical series, whenever the metal placed above hydrogen or the metal, if the metal is found to have negative reduction potential value, so those metal must undergo oxidation process. Similarly, if the metal found to have positive reduction potential value, so that metal will undergo reduction process. Alright. So in electrochemical series, the zinc found to have minus 0.76 value, which means it is negative value, low value. So therefore, whenever you place a metal rod, especially zinc rod in the zinc sulfate solution, it will undergo only oxidation process. Alright. When the metal rod undergo oxidation process, now what is going to happen over here? So I will explain it. Right. When metal rod undergo oxidation process, which means the metal rod getting dissolved in the solution and considerable number of Zn2 plus ions are getting into the solution. So therefore, here the metal is left behind with considerable number of electrons. So if you say zinc rod, here 2 electron is available per metal atoms. If n number of zinc atoms are enter into the solution, n number of electrons will be left behind on the surface of this metal rod. As a result, due to the excess electron availability, now this rod becomes negative in nature. Alright, so it is surrounded by negative ions, that is electrons. So once the electrons or negative ions are surrounded by this metal rod, now due to the electrostatic force of attraction, it will try to capture the positive ions, right, to attract the positive ions which is available in the solution compartments. So negative layer, subsequently there will be a positive layer. So therefore, right, negative layer followed by positive layer. Once positive layer is formed on the surface, again will try to attract the negative layer, that is due to electrostatic force of attraction. So positive layer followed by negative, negative followed by positive layers. So due to this formation of the double layers, one layer, second layer, one layer, second layer. So this is called Helmholtz electrical double layer. Now due to the formation of electrical double layer on the surface of this metal rod, it develops a potential difference between solution and metal rod. So that potential difference is known to be electrode potential. Alright. So the electrode potential is represented as E. The electrode potential is nothing but due to the formation of layer, positive and negative layers between metal rod and the solution compartment, there develop a potential difference. So therefore electrode potential is defined as is a tendency of metal rod to undergo either oxidation or reduction process. Okay, that is called electrode potential at standard conditions at 25 degree centigrade. Alright. This is one concept, and the second concept is going to be reduction process. Let us take copper, right? Now I am going to take copper rod, and the copper rod is going to be immersed in the copper sulfate solution. So this is copper sulfate solution. Now I am going to place a copper rod in the copper sulfate solution. Now here also the copper rod consists of copper atoms. The n number of atoms will be available, and these atoms, copper atoms, are binded together with the help of valence electrons. Now we are going to add particular number of electrons, right? Maybe 2 number of electrons to the electron deficient spaces which are available in the electrolyte compartment. As I told you earlier, electrolyte is nothing but it is a molten salt solution. Now we are going to give at least 2 number of electrons per atom to the molten salt solution. Now what happens over here, when you supply electron, copper is available in the form Cu2 plus. When you supply electrons to this electron deficient spaces, it gets reduced and becomes Cu2 plus. Cu2 plus becomes Cu0, or we can represent as Cu. So copper atom is formed, or we can say copper get reduced and it forms copper atoms. Now this copper atom will be deposited on the surface of this metallic compartment. You can ask me why this copper get reduced, because as I mentioned earlier in electrochemical series, the copper found to have positive reduction potential value. So that means the metal is having positive value 0.34 value. So because of this nature, the copper always undergo reduction process, which means copper always try to get the electron or gain the electron from the electron source. Okay, so it will be converted into copper atom. The copper atom will be deposited on the surface. Meanwhile, the copper will get a positive sign, because here not only reduced atom, even the copper positive ion will also try to approach this copper rod. As a result, a positive layer will be formed on the surface of this metallic compartment, metal rod. Now once metal layers, the positive layer is formed on the surface, it will, due to the electrostatic force of attraction, it will capture the negative ions, or it will attract the negative ions. So due to this process, again one electrical double layer will be formed, and this layer is otherwise called as Helmholtz electrical double layer. And due to the formation of this layer, again it creates a potential difference between metal rod and solution compartment, that is electrolyte compartment. As a result, what happens? It creates a potential difference. So therefore, according to the principle, electrode potential is nothing but the tendency of metal to undergo either oxidation or reduction is called electrode potential. So during both the process, right, both oxidation and reduction process, it develops a potential difference. So that difference is called as electrode potential. All right. Now how we can measure the electrode potentials? So basically, it is impossible to measure the electrode potential E, that is E value. It is impossible to measure the electrode potential without the help of any reference electrodes, right? Now we are going to focus about reference electrodes. So basically, I hope you might have come across the concept of SHE, that is standard hydrogen electrode. During the +2 level itself, you must come across this concept, right? If you want to measure the amount of potential which is developed across this surface during either oxidation or reduction process, you must have one reference electrode. The best reference electrode is going to be standard hydrogen electrode. It's called C. So how we can construct this electrode? So basically, The standard reference electrode can be constructed in the laboratory with simple experiments, using simple components, right? See, now we have to take one beaker, and in that beaker we are supposed to take 1 molar hydrochloric acid. In that I supposed to place a platinum electrode. This is a kind of inert electrode, right? This is a platinum wire. Now I have to pass 1 atmosphere hydrogen gas. 1 atmosphere hydrogen gas has to be passed through this electrode compartment. Now it is bubbled through the solution, so bubbles will be coming out from this compartment. Now during this process, what happens? There will be a oxidation reduction process will be taking place depending upon the type of electrode coupled with this electrode. Basically, standard hydrogen electrode is going to be a primary reference electrode, because so basically the reference electrode can be defined as 2 categories. One is called a primary reference electrode. The second one is going to be secondary reference electrode. Now what is the difference between primary and secondary reference electrodes? So basically, the primary reference electrode, it cannot change the electrode potential value with respect to the environmental factors like temperature or concentration or atmosphere conditions. But when you look at the secondary reference electrode, it will give different amount of output with reference to the type of electrolyte or the concentration of electrolyte, or temperature and pressure and all. So therefore, this electrode is known to be primary reference electrode, and the electrode potential value of this electrode is always kept as 0, that is arbitrarily fixed as 0 at any conditions. Alright, now we are going to utilize this electrode to measure the electrode potential value of one unknown electrode. Now we are going to take zinc electrode as a representative one, right? Now I am going to take I am going to couple this zinc electrode with this standard hydrogen electrode. So this is zinc rod. Now the zinc rod is placed in the zinc sulfate solution. So this is called off cell. Now this off cell has to be connected with this reference electrode through an electrical circuit, and this must be connected through one potentiometer. Now we have formed one complete cell, and this kind of cell is known to be electrochemical cell. Electrochemical cell. All right, friends. So what do you mean by electrochemical cells? So basically, the cells are divided into 2 classes. One is electrochemical cell, and another one is going to be electrolytic cell. So EC stands for electrochemical cell, and EL stands for electrolytic cell. All right. Now, in fact, we have constructed an electrochemical cell, and in the left hand side we have zinc rod, zinc electrode, and in the right hand side we have standard hydrogen electrode. So where we placed one reference electrode, that is primary reference electrode. This is hydrogen H plus solution. This is the passage of H2 gas, and this is zinc rod. Now the zinc rod is connected through potentiometer, and this is connected with reference electrode. Now this is a complete electrochemical cell, and if you want to reduce the liquid junction potential, these 2 compartments, this is one compartment and this is another compartment, these 2 compartments has to be connected through one salt bridge. The main purpose of keeping the salt bridge is it is used to eliminate the liquid junction potential. If you do not eliminate, it will interpret with the cell output. All right. And if these 2 electrodes are connected together, as I said earlier, it can perform as an electrochemical cell. Now what is the principle of electrochemical cell? So electrochemical cell is a device in which chemical energy is converted into electrical energy, which means some chemical reactions, maybe oxidation or reduction or even redox reaction, will be taking place in both the compartments, and that is responsible for the production of EMF in the electrochemical cell. Now it will produce an output, particular output. That output is measured with the help of this equation. E cell is equal to E right minus E left, which means E right stands for electrode potential value of right hand side electrode. E left is nothing but electrode potential value of left hand side electrode. Now you can ask me a question, sir, which one must be kept as anode, which one must be kept as cathode at right hand side? Now, according to the IUPAC, which means International Union for Pure and Applied Chemistry, it tells about if you want to construct an electrochemical cell, you're supposed to keep anode in the left hand side and the cathode in the right hand side. Anode and cathode. Alright, now why you are keeping the zinc rod as anode? So now according to the IUPAC principle, if the metal or if the component having negative value or lower value, that must be placed in the left hand side electrode, right? The negative or low must be in your left hand side. Similarly, if the metal or the component is having positive value or a higher value, that must be placed at your right. Okay, so this is 0. As I mentioned earlier, the reduction potential value of oxygen, Sc is going to be 0, and the reduction potential value of zinc is going to be minus 0.76. So when you compare these two compartments, this is lower value and compare with this part. As a result, I kept this electrode in the left hand side and this one in the right hand side electrode. Alright, now when you couple these two together with the help of this potentiometer, you could find after some time, you could find some deflection. Now, you could get some deflection in the potentiometer. So, it indicates that it has produced some electricity. Now, how much amount of electricity it will produce? So, it is a very simple equation, that is E cell is equal to E right minus E left. So, E right is nothing but reduction potential value of right hand side electrode, that is going to be 0, and E left is nothing but reduction potential value of left hand side electrode, that is minus 0. That is minus value minus 0.76. So, which is equal to minus of minus becomes plus 0.76 voltage. So, this is the amount of electricity it can produce. Now, you can ask me what is the application of this cell. So, if you constructing this cell, initially you just imagine this is 0, which means that we do not know the reduction potential. Basically, this minus 0.76 can be take it from the electrochemical series. If we do not know the value of this reduction potential value of that particular metal, we can take it very easily. Alright. Okay, we will discuss later. So, the complete cell output is going to be plus 0.76. Now, you can ask me, so what is the kind of chemical reaction will be taking place during this production of EMF? Say for example, at anode. So, according to the principle, IUPAC principle, if you keep anode, here always oxidation is going to take place. Oxidation, and in the cathodic compartment, always reduction is going to take place. Now, what is oxidation reaction? Oxidation is nothing but, as I mentioned earlier, zinc composed of zinc atoms. Now, the zinc atom will try to get dissolved in the solution, which means considerable number of zinc ion will enter into the solution compartment. Now, Isren get oxidized, it will be converted into 2 plus 2 electron. So, this is called oxidation. This will be taking place at anode. So, at anode, oxidation reaction will be taking place. Alright. And what is the reduction? At cathode, reduction reaction will be taking place. Now, this zinc, that is from the anode compartment, the anode will try to give 2 number of electron, and these 2 electron, 2 plus 2 minus electron, 2 electron will get consumed by the 2 H plus, which is available in the solution compartment. Now, it get reduced and it forms H2 gas. So, therefore, when you supply 2 number of electrons, the 2 number of H plus get reduced and it forms 1 mole of H2 gas. As a result, when the reactions get progressing, now considerable amount of H2 gas is eliminated from the right hand side electrode, that is cathode compartment. So, therefore, due to the evaporation of hydrogen from a cathode compartment, the concentration of this H plus is getting decreased. Meanwhile, the concentration of Zn 2 plus getting increased. However, the metal ions available in the zinc rod is getting reduced because considerable number of metal ions are getting into the solution compartment. So, this process, if the process are happening together, both oxidation and reduction occurs together, that is called a redox reaction. The redox reaction is responsible for the production of this much amount of electricity in the particular electrochemical cell. So, this is the one concept which is used to measure the electrode potential of this particular cell. Okay, and the second one. Okay, all right friends. Well, the electrode potential of any electrode can be calculated using this reference electrodes. This is one method. And the second method is going to be this a measurement of electrode. This is a fourth specific objective, measurement of single electrode potential. And one method is going to be with the help of reference electrode, we could be able to calculate the electrode potential value of any unknown method and the any unknown electrode. And the second method is going to be measurement of electrode potential with the help of Nernst equation. Nernst equation. So, Nernst equation is highly useful to calculate the reduction potential value of any unknown electrode. Say for example, you do not have any reference electrode to calculate to measure the electrode potential value of the given unknown electrode. Now, at this stage you can go for the kind of theoretical method called Nernst equation. Now, let us consider the following reversible reaction, that is M. Wherever I used to write M, this stands for metal. If I write Mn plus, it is nothing but metal ions plus n number of electrons. If n number of electrons are added together, it becomes n. So, it is a forward reaction, this is called reduction and this is going to be a reversible reaction. The forward reaction is called reduction and the reversible reaction is called oxidation. Now, let us consider this kind of general form of redox reaction. Now, for this kind of redox principle or in any case, any reversible system, if any reversible system is taking place, there will be a change in the three thermodynamic parameters. Those parameters are G, that stands for Gibbs energy, and H, that is enthalpy, and S, that is entropy. So, G stands for Gibbs free energy, S, entropy of the system, that is the heat of change of the reaction, and S is nothing but entropy, that is the randomness in the system. And if any reaction is taking place, all these three parameters will get changed in the for the particular type of chemical reaction, that is reversible reaction. All right. Now, there will be a change in the Gibbs free energy. When the reaction gets progressed, there will be a change. The G is nothing but Gibbs free energy. The delta indicates there is a small change in the Gibbs free energy is related to the equilibrium constant. It's a kind of reversible reaction, so it must have an equilibrium constant. So, that is related to the equilibrium constant RT ln K plus RT ln product by reactant. Now, this is product part, this is reactant part. That too, the metal now here is available in the form of solid state and here it is available in the form of aqueous form, that is metal ions, right. Now, whenever any chemical reaction, that is reversible reaction is taking place, it is related to the change in the Gibbs energy and equilibrium constant. Now, if the reactions are taking place under standard conditions, now delta G is equal to RT, where R is nothing but gas constant and T is nothing but temperature and K becomes constant ln K, and now this entire parameter is taken as delta G naught if it is happened in the standard conditions. So, therefore, this equation can be modified as delta G is equal to delta G0 plus RT ln product by reactant. All right. So, this is equation 1. So, this equation is known as want Hoff equation. Want Hoff isotherm equation is a famous equation. This is useful to very much useful to calculate the change in the free energy of the particular system. All right. Now, according to the thermodynamic principle, whenever the change is happening in the chemical reaction or whenever the change is happening in the Gibbs free energy delta G, okay, is related to the production of EMF NFE, okay, which means if any reversible reaction is taking place, there will be a change. So, what type of change will happen? There will be a decrease in the free energy. So, the decrease in the free energy is related to the formation or production of EMF in the particular system. Now, what is meant N over here? N is nothing but number of electron get transferred from anodic to cathodic compartment, and N is nothing but Faraday. 1 Faraday is equal to 96,500 coulombs. And E is nothing but electrode potential, or we can call it as EMF. Now, this is going to be this can be written as minus NFE, and this is equation 2. Delta G is equal to minus NFE. And when you compare the equation 1 and 2, the left hand side part are equal, so right hand side also must be unequal. So therefore, when you equate equation 1 and 2, it becomes minus NFE equal to delta G naught plus RT ln product by reactant. Are you clear? So now this is very simple. This is based on want of isotherm equation, and another thing, this is based on whenever the change is happening in the system, there will be a decrease in the free energy. So due to the decrease in the free energy, it leading to the production of EMF. Now the left hand side of the equations are equal. Now I am going to equate the equation number 1 and 2. So when you equate, I will get the equation like this: minus NFE is equal to delta G0 plus RT ln product by reactant for this particular type of reaction. Or it can be modified as delta G0 plus RT ln, here the product is going to be metal ion. There is concentration of, not metal, this is a metal, solid metal, divided by concentration of metal ion, that is in the reactant part, Mn plus. Okay, so this is the equation. Alright friends. So according to the want of isotherm equation, NF as NFE is equal to delta G0 plus RT ln product, this is metal divided by metal ions. Or you can be written as RT ln K itself plus RT ln, this is based on the previous equation, metal divided by metal ion minus NFE. Now I just want only the electrode potential value of that particular metal. So we can divide the entire equation with the help of minus NF. Okay, so this equation is divided by minus NF. So it becomes minus the NFE divided by minus the NF equal to minus RT ln K divided by NF. So this is becomes minus, because we are going to divide this equation with the help of minus NF divided by NF ln, here the activity of the pure metal is always going to be 1. So 1 divided by Mn plus. Alright, now it becomes E, that is electrode potential. So now this is all going to be a constant. R is constant, T is constant, N is number of electron transfer, that is going to get kept as constant, and Faraday. So it becomes K is nothing but equilibrium constant. Now all becomes constant values. Again become constant, so we can modify this equation as E0. Okay, so the entire constant is kept as E0 minus RT by NF into, now we are going to convert this form into another form, that is log of, this is natural log of 2.303 into 1 by Mn plus. So which is equal to E0. Now I am going to modify this equation again, E equal to E0 plus RT by NF into log of 2.303 into Mn plus. Now this is available in the form, of log 1 by A. Now I am going to convert this term as a log A. If I modify this equation log A, you put minus. Okay, so now minus into minus becomes plus. So therefore E equal to E0 plus RT by NF, the log of 2.303 into metal ion concentration. Now this is constant, gas constant, which is equal to R is equal to 8.314 joule per mole, and N is nothing but number of electron transfer that depends upon the valency of the particular metal, and F is nothing but Faraday. It's 1 Faraday is equal to 96,500 coulomb. So which is equal to, if you simplify this entire equation, T is nothing but temperature, that is 25 degree. Now we can convert this Celsius into Fahrenheit. It becomes 298 Kelvin. When you simplify all this equation, you will get E equal to E0 plus 8.314 into 298 into 2.303 divided by 96,500 coulomb n into log of m n plus. It becomes E0 plus 0.0592 divided by n into log of m n plus. This equation is known to be electrode potential value for the particular metal. So using this Nernst equation, we could able to calculate the electrode potential value of any unknown electrode. Now you can ask me, so what are the factors which will influence the electrode potential of this particular metal? Alright, there are three parameters. Basically there are three parameters which will determine the electrode potential value of any unknown electrodes. So those parameters are temperature. The first one is going to be temperature, the second one is going to be a concentration, and the third one is going to be a nature of metal. Okay, all these three parameters will influence the electrode potential value. Say for example, if the temperature of the reaction process is more than room temperature, so therefore it will accelerate the reaction rate, and if the concentration is more, then we can get different amount of electrode potential. Alright, as I mentioned earlier, the oxidation and reduction tendency of the metal is depends upon the nature of the particular metal. Right, if you take a zinc metal, it will undergo oxidation process. If you take copper metal, that must undergo reduction process. So whatever may be the type of metal, we can able to calculate both oxidation and reduction potential. Now what is the difference between oxidation and reduction potential? Both are equal except the numerical value of oxidation and reduction potential value remains same except the sign. Say for example, if you take zinc electrode, so according to the electrochemical series, the reduction potential value of the zinc is going to be minus 0.76. However, the oxidation potential value of zinc is going to be plus 0.76. Both are having same numerical value except the sign. This is the case for zinc. And if you take it as a copper, here for copper, the reduction potential value of copper is going to be plus 0.34, and the oxidation potential value of the copper is going to be minus 0.34. So therefore we can clearly understood that the numerical value of both oxidation and reduction potential value remains same, but the sign is going to be a different parameter. Okay, so that's all about the electrode potential and its measurement. So I conclude once again, we can the main concept of this topic is going to be electrochemistry and terminology, where we focused about the following concept: oxidation, reduction, redox principle, and electrode potential and its measurement. Here oxidation nothing but removal of electron from the particular metal, so therefore we are going to convert metal into metal ions. Reduction nothing but we are going to convert the metal ions into corresponding metal by giving or supplying considerable number of electron to the electron deficient species. Alright, and what is the redox principle? Redox is nothing but whenever these two reactions are happen together, both oxidation and reduction in a particular system, that's called redox principle or redox system, which is responsible for the production of EMF. Alright, and the fourth one is going to be electrode potential. So when the metal rod is placed in one salt solution, there develop a potential difference. That difference is called electrode potential. It may give oxidation potential or it may give the reduction potential. And the fifth one, how we can measure it? Basically, it is impossible to measure the electrode potential at normal conditions. So therefore, if we want to measure the electrode potential, we must get the help from either reference electrode or we can go for calomel electrode. That is Nernst equation. So it is very essential to measure the measurement of electrode potential. The fifth one is measurement of electrode potential. The electrode potential can be measured with the help of one reference electrodes. We can use any type of reference electrode. We can go for She or calomel electrode or some other reference electrodes, even saturated calomel electrode. Any type of electrode can be used, reference electrode can be used to calculate the electrode potential value of any unknown electrode. And in addition to this, the electrode potential value of the particular unknown metal can be calculated with the help of Nernst equation, and this is the equation which can be used to measure the electrode potential. Alright, now you can ask me what are the factors which will influence the electrode potential. Basically, there are three parameters which will determine or design the electrode potential. They are temperature, concentration and nature of metal. If the temperature is more, then the forward reaction will be more. If the concentration is more, the equilibrium will be attained very easily. And third one, nature of the metal. So the nature of the metal also will greatly influence the potential value of the particular metal. So that's all about the today's topic. We'll see it again. Thank you.